These are the notes for geometric decreasing sequences. These are sequences that decrease as we go, and it's decreased by division. So looking at this sequence, to go from 2500 to 500, that's dividing by 5. And to go from 500 to 100, that's dividing by 5. So the multiplier is dividing by 5. So to find the next term in the sequence, I would divide 100 by 5 and get 20. To get the 0 term, instead of dividing by 5, I would multiply by 5. 2,500 times 5 is 12,500. To write the equation for the sequence, we start t sub n equals, now dividing by 5 can be written as 1/5. The n is the power, and then we multiply it by the 0 term. So dividing by 5 turns into 1/5, and the 0 term goes here. To check to see if it works, we could choose the second term of the sequence. So we would take 1/5 to the second times 12,500. 1/5 to the second is 0.2 squared, which is 0.04. Then we take that times 12,500, and I get 500. So the second term is 500, and we are correct. For our second example, you'll notice that to go from 120 to 60 is divided by 2. And going from 60 to 30 is also dividing by 2. So our multiplier is divide by 2. To find the next term in the sequence, I would take 30 divided by 2 and get 15. To get the 0 term, instead of dividing by 2, I do the opposite and multiply by 2. 120 times 2 is 240. The equation becomes t sub n equals, dividing by 2 I write as 1/2, n is the power, multiplied by the 0 term. To see if it works, I could test this on term 2. So I would take 1/2 to the second times 240. 1/2 is 0.5, and 0.5 squared is 0.25. And I multiply that by 240, and I get 60. The second term of the sequence is 60. For our third example, you will notice that 1,600 divided by 4 is 400, and 400 divided by 4 is 100. So our multiplier is divided by 4. To find the fourth term, I would take 100 divided by 4 and get 25. To get the 0 term, I would multiply 1,600 by 4 and get 6,400. The equation for the sequence would be t sub n equals, divided by 4 is 1/4 to the n times the 0 term. To test to see if it works, I'll try term 2. So I put a 2 in for n, and now I solve. 1/4 is 0.25 squared is 0.0625. Then I'll multiply that by 6,400, and I get 400. The second term of the sequence is 400. That checks. For our last example, you will notice that to go from 500 to 100 is divided by 5, and 100 to 20 is divided by 5, so my multiplier is divided by 5. To find the fourth term in the sequence, I would take 20 divided by 5 is 4. To find the 0 term, I would multiply 500 by 5 and get 2500. The equation of the sequence becomes t sub n equals divided by 5 turns into 1/5 to the nth times 2500. Let's test this, see if it works for term 2. So I would fill in a 2 for n. 1/5 is 0.2 squared times 2500. 0.2 squared is 0.04 times 2500 equals 100. So the second term in the sequence should be 100. It checks. One thing to note, when you're turning 1/5 into a decimal, all you need to do is divide. That's how I'm getting 0.2. Then I would take that to the second power. So to turn the multiplier into a decimal, you simply divide.